Okay folks, this is lesson 7-2. This is going to be the second part. We're going to look at examples 3 and 4, finding the area between two curves. We already looked at looking at the two functions, figuring out where our limits are, and doing the upper function minus the lower function integrating. So let's look at this one where it's just not very pretty. If we look at y equals 2 cosine of x and y equals x squared minus 1, you'll notice that you couldn't set 2 cosine of x equal to x squared minus 1 because you can't solve that analytically. So we're going to use the calculator on this one. So step 1, we're going to graph it to find the positions on the plane. Right here, you'll see my graph. This is, I put in 2 cosine of x here and x squared minus 1. And I know 2 cosine of x has an amplitude of 2, so I'm going to go somewhere between, it's going to oscillate between 2 and negative 2. And x squared minus 1, well, it's going to have a y-intercept of negative 1, and it's a parabola. So I'm just going to look from negative 3 to 3 in both the x and the y direction to see where this graph is going to be. When I look at this, I know that this function is y equals x squared minus 1, and this function is y equals 2 cosine of x. And the question is, so this is the area I'm interested in finding. So I need to know what are my limits of integration. I do know just from looking at this that this is the higher function. And if I wasn't sure, I would calculate a value, and if I put in 0, I could see right here it said 2 cosine of x, and here's my cursor, so I know that's the higher one. If I arrow key down, notice now the cursor's down here, and I know that's x squared minus 1, so I know that's the lower function. So right away, when I'm going to write my integral, I'm going to put this one first. So I'm going to write 2 cosine of x minus x squared minus 1. That's going to be my equation to find this area here. But I need my limits of integration, and they're going to have to go from here to here. Doesn't look pretty. This is 2, negative 2. This is negative 1. So let's use technology and calculate our intercepts. So I'm going to calculate my intersect here, and I'm going to take my cursor and move it down. And then I'm going to go to the other side. And I see I'm at negative 1.265424. It's messy. And I can't put that in here, and I don't want to round. So what I'm going to do is I'm going to store this value in my calculator. And we're going to erase this so you can read that. So go back to your work screen and just press X, because that's the last thing X was. And you'll see here's that lower limit. So now I can go to store. It's the key right above the on key. And I'm going to store it as alpha A. That stores it as A. And there it is. The calculator now recognizes this as A. So my lower limit here will be A. Now, I'm going to go back to my screen. I'm going to calculate my other intersect. Another big messy number. So going back to my work screen, I'm going to press X. There's my number. I'm going to store it as B. So now I have an integral. Throw in dx. I can either put this right into my calculator to find out that area, or I can simplify by distributing this negative sign. I'm not big on parentheses, so I think I'll do that. So that'll be my integral from A to B of 2 cosine of x minus x squared plus 1. And now let's just take that over here And we'll just put that right into our work screen. I just went the math key right below alpha and went down to integral. Now I'm going to just plug in that function, 2 cosine of x. Make sure you get that parenthesis around there. Minus x squared plus 1. And I need to integrate that with respect to x. And now this is where you put in your limits. So I'm just going to put in a comma b. And I see that that area is 4.995 cubic units. Or square units, excuse me. So we can find the area using technology when we get a function that can't be done analytically. Okay? So that's that one. Now let's look at, oops. Look at something like this. It says, example 4 says to find the area of the region R in the first quadrant bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. So that's going to look like this region. Notice we've got y equals square root of x. Here is x minus 2. But we can see that would come on down here to negative 2. And here's the x-axis. So we're only looking at this region right in here. That's what we want to find. Well, if we followed the trick we've been using and went from 0 to 4, we would get this whole area. We'd have this triangle involved, and we don't want that. So what we're going to have to do is think, how else can I get this area? One way, I guess, would be to do the whole area and subtract the triangle. That would work. And another way is to just divide this. Right here, I can get this area with just the integral of square root of x. And that would go from 0 to 2. And then and that way I wouldn't get all of this, because just the integral, remember, it just goes to the x-axis. So that would just be this positive area right here. Then I could take and add to that this area by doing what we've been doing, the upper function. So I've got my integral, and I'm going to take the upper function minus this lower function, x minus 2 dx. And that's going to go from 2 to 4. So that would be the other way we can do that. So separate it into 2 regions, and upper one always has to go on top. So I'm going to rewrite this here. Using the fundamental theorem of calculus is how we're going to anti-differentiate it. So we want to write it in easy to anti-differentiate terms. So we'll go 0 to 2, and instead of saying square root of x, we're going to say x to the 1/2 power. And now I'm going to go 2 to 4, and I've got x to the 1/2 minus, and I'm going to distribute this negative sign. So minus x plus 2. Now remembering our fundamental theorem, now we take the antiderivatives. So think about adding 2 halves here. That would give me x to the 3/2. And dividing by 3/2, or times 2/3. And I've got this, and then, excuse me, that'll go from 0 to 2. And then this, again, 2/3 x to the 3/2 minus x squared divided by 2 plus 2x, and that's going to go from 2 to 4. Okay? Now if you plug in your numbers here, if you put in 2, I've got 2/3 times 2 to the 3/2 and minus, and then you put in your 0, you're just going to have 0. So that's the first one. Plus, now let's do the second one. I've got 2/3 times, I'm going to start with my 4 to the 3/2 minus 4 squared over 2 plus 2 times 4. All of that minus, and if you put in, now I've got to put in my 2, so 2/3 times 2 to the 3/2 minus 2 squared over 2 plus 2 times 2. So I've got all this to evaluate. Let's go with another step here. Running out of board. So I've got 2/3, and 2 cubed is 8. And the square root of 8, I'm going to call it 2 square root of 2. Okay? And it's minus 0, so that's the area, that's my first area. Plus, now for my second area, I've got 4 cubed, which I'm going to take the square root of 4 first because it's easier. So square root of 4 is 2. 2 to the 3rd power is 8. So this whole thing goes to 8. 2 times 8 is 16. I've got 16/3 there. Minus 4 squared is 16 divided by 2 is 8 plus 8. So that's this minus this one, 2 cubed, 8 square root, 2 square root of 2 times 2, 4 square root of 2, excuse me, over 3 minus 4 divided by 2 is 2 plus 4. So that's where this is going to come out. 2 times 2, I've got 4 square root of 2 over 3 here. I have 16/3. 8 is going to be, let's see, let's get our thirds off. 16/3 minus 24/3. Oh, let's just make that go away. What am I thinking? And here I've got 4 square root of 2 over 3. Minus 2 plus 4 is 2. I'm going to make it thirds because I'm going to need that. So I've got 6/3. This cancels out, and I have 16/3 plus 6/3, 22/3. So, what did I do?
Minus 6/3. Because you have 2.
Ah, 16. Oh, there's a negative sign here. Excuse me. Minus 6/3. Don't forget to distribute your negative sign, folks, because this was a minus here. So this is going to be minus a positive 6/3. So I've got 10/3 for my answer. Thank you, Ms. McGuire. It's good to have a good camera person. So be careful with your fractions. Be careful to distribute your negative sign, or you'll end up like me in a bad place. Now I'm going to check that real quickly because you want to make sure all your work gets checked. So I'm just going to put these, I'm going to do the whole thing in my calculator. I'm going to first take the, I want the integral from 0 to 2 of x squared. So I'm going to say square root of x with respect to x from 0 to 2. And I want plus, now I'm going to put my other integral in there. And that's going to be the square root of x minus x plus 2. Again, with respect to x, and this is going to go from 2 to 4. And it'll take a minute to calculate that, but you notice 3 1/3. So we're at 10/3, and this all worked out. If I would have gone with my 22/3 and saw this, I would have right away gone and looked for where I lost my negative, because you know it's usually a lost negative. So hope this helps, and see you in class.